Hello students, you are welcome to 5th period class on first PUC mathematics, very important chapter, that is second chapter, relations and functions. Dear students, I think in the previous class we have practiced the definitions, particularly based on relations. So that is the definition of a relation, definition of a domain, definition of a range, and a definition of a codomain. So that and all we have learnt in the last video class. In this video class, let us know the some problems based on these definitions, that is particularly the exercise 2.2 exercise. Understand children? The exercise 2.2 exercise problems along with some worked example problems in this class we have to discuss. Okay children, under that we have the first question, that is, let capital A is equals to 1 comma 2 comma 3 comma 4 comma 5 comma 6. Children, as we know all, this is a set they are given us. Okay, define a relation capital R. So here we have to exhibit, here we have to present the relation from A to A. So here we have to take the domain and range elements, that is 1 2 3 4 5 6. So that is capital R is equals to set x comma y such that y is equals to x plus 1. Children, here we have the relation, that is y is equals to x plus 1. So this is the very important thing you have to keep in your mind. Children, let us take down the answer. Before that, we'll see. Next, depict this relation using an arrow diagram. So here we have to draw the arrow diagram also, and also here we should write domain, range and codomain. It's very simple problem. So definitely we can expect these type of problems for 3 mark question or 5 mark question, children. So don't neglect, just listen to me, correct agi follow up ಮಾಡ್ಕೊಂಡು ಹೋಗಿ. ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿದೆ. First we have to consider the relation, that is capital R is equals to x comma y such that y is equals to x plus 1. Children, this is what we called as relation. So they are given us in set builder form. So we have to convert this rule form or set builder form into roster form. It's very simple, children. Let us write relation as it is. Open the bracket. Now we have to write the order pairs. Now we should write the order pairs, because what do you mean relation? Relation is a subset of Cartesian product. So what we can see in the Cartesian product? Definitely we can see in the Cartesian product, that is order pairs. So here also we should write the order pairs just by seeing the rule. So here we have the rule, that is y is equals to x plus 1. Children, so here the numbers in the place of x and y are nothing but 1 2 3 4 5 6. Understand children? The numbers in the place of x and y are nothing but 1 2 3 4 5 6. So here children, how would like to take in place of x, that is 1. So what will be the y value? As we know all, in place of x, suppose if I take the value 1, the value of y is 2. So 2. Open the bracket. Here I would like to take in place of x, that is 2. So what will be the value of y? x place ಅಲ್ಲಿ ನಾನು 2 ತಗೊಂತೀನಿ. ಇಲ್ಲಿ 2 ಬದಲು ಏನಾಗುತ್ತೆ? 2 plus 1 3 ಆಗುತ್ತೆ y value. So next, if I insert in place of x, that is 3. So what will be the y value? 3 plus 1 4. Understand children? Again, if I insert in place of x, that is 4. What will be the y value? 5. Understand children? So immediately if I insert in place of x, that is 5. x place ಅಲ್ಲಿ 5 ತಗೊಂಡ್ರೆ y ವ್ಯಾಲ್ಯೂ ಏನಾಯಿತು? 5 plus 1 6 ಆಯಿತು. Enough. So you should not do Next again, so don't take in place of x, that is 6. x place ಅಲ್ಲಿ 6 ತಗೊಳಕ್ಕೆ ಹೋಗ್ಬಿಡ್ರಿ, ಯಾಕಂದರೆ y ವ್ಯಾಲ್ಯೂ ಏನಾಯಿತು 6 + 1 7 ಆಗುತ್ತೆ. ಆದರೆ yಗೆ 7 ಇಲ್ಲಿದೆಯಾ? ಇಲ್ಲ. ಇಲ್ಲೇನಿರಬೇಕು, ಎಕ್ಸಲ್ಲಿ ನೀನು ತೊಗೋಬೋದು, ಎಕ್ಸಲ್ಲಿ ಬೇಕಾದರೆ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ ಎಕ್ಸ್, ದಟ್ ಈಸ್ 5, ಬಟ್ ವೈ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಕನ್ಸಿಡರೇಷನ್ ಆಗಲ್ಲ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ಸೆಟ್ ಬಿಲ್ಡರ್ ಫಾರಮಲ್ಲಿರ್ತಕ್ಕಂಥದ್ದನ್ನು ರೋಸ್ಟರ್ ಫಾರಮ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ರೋಸ್ಟರ್ ಫಾರಮ್. ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ರೋಸ್ಟರ್ ಫಾರಮ್ ಚಿಲ್ಡ್ರನ್. ಸೊ ಇಮಿಡಿಯೇಟ್ಲಿ ಐ ವುಡ್ ಲೈಕ್ ಟು ಟೇಕ್ ದ arrow diagram. So arrow diagram, children, here I would like to take this one as x and this one as y. So let us write down the x elements, that is 1 2 3 4 5 6. Again here also I would like to write 1 2 3 4 5 6. Children, now we should match, mapping ಮಾಡೋಣ. 1, 2. ಸೊ 1 ಏನಾಗ್ತಾ ಇದೆ, 2ಗೆ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತಾ ಇದೆ. 2, 3. 2 ಏನಾಗ್ತಾ ಇದೆ, 3ಗೆ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತಾ ಇದೆ. 3, 4. 3 ಏನಾಗ್ತಾ ಇದೆ, 4ಗೆ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತಾ ಇದೆ. 4, 5. 4 ಏನಾಗಿದೆ, 5ಗೆ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತಾ ಇದೆ. 5, 6. 5 ಏನಾಗ್ತಾ ಇದೆ, 6ಗೆ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತಾ ಇದೆ. ದಟ್ ಮೀನ್ಸ್ ದಟ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ arrow diagram. This is what we called as arrow diagram. So this is what we called as arrow diagram. So first one is over. It's very simple children. Next write down the domain, range and codomain. It's very simple. Let us take the first domain of R. Domain of R. So domain of R is nothing but the connective elements of first set to second set. Here the connective elements are 1 2 3 4 5. What do you mean domain? Domain is nothing but in a order pair. First elements are called as domain elements. See, 1 is a domain, 2 3 4 5 are nothing but domain elements. In a order pair, the first elements, in a order pair, the first elements are called as domain. In a relation capital or the order pair, first elements are called as domain elements. Here domain elements are 1 2 3 4 5. Enough. We should not take 6. 6 is not a domain element. That's why I am telling that the connective elements of first set to second set we called as domain elements. The connective elements of first set to second set we called as domain elements. Or in a relation capital or the order pair first elements. The order pair first elements are called domain elements. Next, let us take down the second one, that is range of R. Range of R. So here range is nothing but in a relation capital or the order pair second elements. The order pair second elements. See, 2 3 4 5 6. 2 3 4 5 6 are nothing but range elements, because the connective elements of a second set to first set, the connective elements of a second set to first elements are called as range of R. So here range of R is nothing but 2 3 4 5 6. They are nothing but range of R. Next we will see the codomain. Codomain of R. Codomain of R. Children, it's very simple. Codomain of R. It's very simple children. All the elements of second set we called as codomain of R. all the elements of second set we called as codomain of OR. So that is 1, 2, 3, 4, 5, 6. They are nothing but codomain of OR. All the elements of second set we called as codomain of OR. All the elements of second set we called as codomain of OR. See children? So this is the way we are going to present the answers. It's very simple children. It's very simple children. So once again let me explain the answer. So here they are given us the rule method, that is y is equals to x plus 1. Children, that is capital R is equals to set x comma y such that y is equals to x plus 1. So this is what we called as rule. So here we have taken in place of x, that is 1, the value of y is 1 plus 1, that is 2. And again if I take in place of x, that is 2, the value of y is 2 plus 1, that is 3. Again if I take in place of x, that is 3, 3 plus 1, the value of y is 4. Suppose if I take in place of x, that is 4, 4 plus 1, the value of y is 5. And finally we should take in place of x, that is 5, the value of y is 6. So this is what we called as roster method of representing the relation. The next one is that is arrow diagram. So here I have taken x and y. So here we should take all the elements of set A, that is 1, 2, 3, 4, 5, 6. And in y column also we should take all the elements of the given set, that is 1, 2, 3, 4, 5, 6. Here we should connect only the mapping relation elements. 1 connected to 2, 1 to 2, 2 to 3, 2 connected to 3, 3 to 4, 3 connected to 4, 4 to 5, 4 connected to 5, 5 to 6, 5 is connected to 6. Understand children? So this is what we call as arrow diagram. Next, just by seeing the arrow diagram, we should write domain of OR, range of OR and codomain of OR. It's very simple children. So here the connective elements of first set to second set we called as domain of OR. The connective elements of first set to second set we called as domain of OR. Here domain elements are nothing but 1, 2, 3, 4, 5. So we have taken domain of OR, that is 1, 2, 3, 4, 5. So also by using definition, what do you mean domain? In a relation capital OR, the order pair first elements. In a relation capital OR, the order pair first elements are called as domain of OR, that is 1, 2, 3, 4, 5. See children, in a relation capital OR, the order pair first elements, they are nothing but domain of OR. Next we should go for range of OR. What do you mean range of OR? In a relation capital OR, in a relation capital OR, the order pair second elements we called as range of OR. So here range of OR is nothing but 2, 3, 4, 5, 6. That's we have taken 2, 3, 4, 5, 6. Or in a arrow diagram, the connective elements of second set to first set we called as range of OR. The connective elements of second set to first set we called as range of OR. So here range elements are 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And finally codomain of OR. Codomain of OR is nothing but all the elements of second set. All the elements of second set we called as codomain of OR. Here codomain of OR is nothing but 1, 2, 3, 4, 5, 6. See children, codomain of OR is nothing but 1, 2, 3, 4, 5, 6. Children, understand? I hope you are understanding the answer clearly. Okay children, just you pause the video and take down the notes. Next I would like to take the second problem based on this concept. Okay children, next let me take the second problem. Second problem. Let me take the second problem, that is let capital A is equals to 1 comma 2 comma 3 comma dot 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 14. Define a relation or define a relation capital R from A to A by capital R is equals to set x comma y such that 3x minus y which is equals to 0. 3x minus y which is equals to 0. So here x comma y, there belongs to set A. Both x comma y belongs to set A. Children, here we should write down its domain. Write its domain, range and codomain. Children, you can do yourself. I need not to explain you people more. You can do yourself. Children, so whatever the question, we have to first pick the given set builder form. So here the given set builder form, that is 3x. I am doing solution. I am doing answer. Children, I am doing answer, that is here we have the relation, that is 3x minus y which is equals to 0. Children, let us write 3x as it is. If I send minus y to right side, the value is plus y. Or I can write this one as y is equals to 3x. Let us call this one as equation 1. So here they are given us x comma y, both the elements of order pair x comma y, they are belongs to the set 1, 2, 3, 4, 5 dot 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 up to 14. Children, now let us frame or form the relation. Now let us frame the relation. Children, as we know all how to frame the relation. So here they are given us one rule, that is a 3x minus y which is equals to 0. 3x minus y which is equals to 0. Let us write 3x as it is. If I send minus y to right side, the value is plus y. Or if I take y is equals to 3x, I can take y is equals to 3x. Children, here also we should fill the order pairs just by seeing the relation. Suppose if I take in place of x, that is 1. Suppose if I take in place of that is 1, so the value of y is 3 ones are 3. Close the bracket. So here I would like to take in place of x, that is 2. Suppose if I take in place of x, that is 2, the value of y is 3 2s are 6. Children, listen to me carefully. Again, if I take in place of x, that is 3. Suppose if I take in place of x, that is 3, the value of y is 3 3s are 9. Again, if I take in place of x, that is 4. If I take in place of x, that is 4, the value of y is 4 3s are 12. Enough, children. Suppose if I take in place of x, that is 5, the value of y is 5 3s are 15. But here 15 is not there in the place of x and y. That's why, so this is what we called as relation. Understand, children? Here the relation is 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 3. Almost all the multiples of 3. 1 3s are 3, 2 3s are 6, 3 3s are 9, 4 3s are 12. Understand children? Here I would like to answer once again. If I take in place of x, listen to me carefully. If I take in place of x that is 1, the value of y is 3 1s are 3. If I take in place of x that is 2, the value of y is 3 2s are 6. If I take in place of x that is 3, the value of y is 3 3s are 9. If I take in place of x that is 4, the value of y is 4 3s are 12. Just by saying this one, we can write easily domain, range and codomain. Children, here I can write domain of R. The domain of R is nothing but, as we know according to definition, in a relation capital R, the first set elements are called as domain elements. 1, 2, 3, 4 are nothing but domain. 1, 2, 3, 4 are nothing but domain. Next, range of R. Range of R is nothing but, in a relation capital R, the second elements of order pair. 3, 6, 9, 12. Understand children? What do you mean range? In a relation capital R, the order pair second elements are called range. 3, 6, 9, 12. 3, 6, 9, 12. 3, 6, 9, 12. Next, codomain. Codomain of R. So here the codomain of R is nothing but whole set B. All the elements of set B. So here B set is, this is what we called as A set and this is what we called as B set. Here set A and set B both are belongs to the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The whole set B is called as codomain. So here codomain elements are nothing but 1, 2, 3, dot, dot, dot up to 14. See children, how simple we are present the answers. I hope you are getting idea. Just you pause the video and take down the notes. Okay children, thank you. In the next class, I would like to continue the same concepts. Thank you children. Keep learning, keep practicing your mathematics, that is first PUC mathematics. Thank you.